Welcome to the presentation on adding and subtracting fractions. Let's get started. Okay, let's start with what I hope shouldn't confuse you too much. This should hopefully be a relatively easy question. If I were to ask you what 1/4 plus 1/4 is, let's think about what that means. Let's say we had a pie and it was divided into 4 pieces. So this is like saying this first 1/4 right here, let me do it in a different color. This 1/4 right here, let's say it's this 1/4 of the pie, right? And we're going to add it to another 1/4 of the pie. Let's make it this one. I thought that was a different color. Let me change the color. Pink. This 1/4, this pink 1/4 is this 1/4 of the pie. So if I were to eat both 1/4s, or 1/4 and then I eat another 1/4, how much have I eaten? Well, you could look from just the picture. I have now eaten 2 out of the 4 pieces of the pie. So if I eat 1/4 of a piece of pie, and then I eat, or 1/4 of a pie, and then I eat another 1/4 of a pie, I will have eaten 2/4 of the pie. And we know from the equivalent fractions module that this is the same thing as I've eaten 1/2 of the pie, which makes sense. If I eat 2 out of 4 pieces of a pie, I've eaten 1/2 of it. And if we look at it mathematically, what happened here? Well, the denominators, or the bottom numbers, numbers in the fraction stayed the same, because that's just the total number of pieces I have in this example, while I added the numerators, which makes sense. I had 1 out of the 4 pieces of pie, then I ate another 1 out of the 4 pieces of pie, so I ate 2 out of the 4 pieces of pie, which is 1/2. Let me do a couple of more examples. What is 2/5 plus 1/5? Well, we do the same thing here. We first check to make sure the denominators are the same. We'll learn in a second what we do when the denominators are different. But if the denominators are the same, the denominator of the answer will be the same. And we just add the numerators. 2/5 plus 1/5 is just 2 plus 1 over 5, which is equal to 3 over 5. And it works the same way with subtraction. If I had 3 over 7 minus 2 over 7, that just equals 1 over 7. I just subtracted the 2 from the 3 to get 1, and I kept the denominator the same. Which makes sense. If I have 3 out of the 7 pieces of a pie, and I were to give away 2 out of the 7 pieces of a pie, I'd be left with 1 of the 7 pieces of a pie. So now let's tackle, I think it should be pretty straightforward when we have the same denominator. Remember, the denominator is just the bottom number in a fraction. The numerator is the top number. What happens when we have different denominators? Well, hopefully it won't be too difficult. Let's say I have 1/4 plus 1/2. Well, let's go back to that original pie example. Let me draw that pie. Okay, so this first 1/4 right here, let's just color it in. That's this 1/4 of the pie. And now I'm going to eat another 1/2 of the pie. So I'm going to eat a half of the pie. So this 1/2, I'm going to eat this whole half of the pie. So what does that equal? Well, there's a couple of ways we could think about it. First, we could just rewrite 1/2. 1/2 of the pie, that's actually the same thing as 2/4, right? There's 1/4 here, and then another 4th here. So 1/2 is the same thing as 2 over 4, and we know that from the equivalent fractions module. So we know that 1/4 plus 1/2, this is the same thing as saying 1/4 plus 2/4, right? And all I did here is I changed the 1/2 to a 2/4 by essentially multiplying the numerator and the denominator of this fraction by 2. And you can do that to any fraction. As long as you multiply the numerator and the denominator by the same number, you can multiply it by anything, and that makes sense because 1/2 times 1 is equal to 1/2. You know that. Well, another way of writing 1 is 1/2 times 2 over 2. 2 over 2 is the same thing as 1, and that equals 2 over 4. And the reason why I picked 2 is because I wanted to get the same denominator here. I hope I'm not completely confusing you. Well, let's just finish up this problem. So we have 1/4 plus 2/4, and we know that we just add the numerators, 3, and the denominators stay the same, 3/4. And if we look at the picture, true enough, we have eaten 3/4 of this pie. Let's do another one. Let's do 1/2 plus 1/3. Well, once again, we want to get both denominators to be the same, but you can't just multiply one of them to get. There's nothing I can multiply 3 by to get 2, or there's no at least integer I can multiply 3 by to get 2, and there's nothing I can multiply 2 by to get 3. So I have to multiply both of them so they equal each other. And it turns out that what we want for what we'll call the common denominator turns out to be the least common multiple of 2 and 3. Well, what's the least common multiple of 2 and 3? Well, that's the smallest number that's a multiple of both 2 and 3. Well, the smallest number that's a multiple of both 2 and 3 is 6. So let's convert both of these fractions to something over 6. So 1/2 is equal to what over 6? You should know this from the equivalent fractions module. Well, if I eat 1/2 of a pizza with 6 pieces, I would have eaten 3 pieces, right? And that makes sense. 1 is half of 2, 3 is half of 6. Similarly, if I eat 1/3 of a pizza with 6 pieces, that's the same thing as 2 over 6. So 1/2 plus 1/3 is the same thing as 3/6 plus 2/6. And notice I didn't do anything crazy. All I did is I rewrote both of these fractions with different denominators. I essentially changed the number of pieces in the pie, if that helps at all. And now that we're at this point, then the problem becomes very easy. We just add the numerators. 3 plus 2 is 5. And we keep the denominators the same. 3 over 6 plus 2 over 6 equals 5/6. And subtraction's the same thing. 1/2 minus 1/3. Well, that's the same thing as 3, oops, that's a 3. 3 over 6 minus 2 over 6. Well, that equals 1 over 6. Let's do a bunch of more problems, and hopefully you'll start to get it. And always remember, you can rewatch the presentation, or you can pause it and try to do the problems yourself, because I think sometimes I talk fast. Let me throw you a curveball. What's 1/10 minus 1? Well, 1 doesn't even look like a fraction. Well, but you can write it as a fraction. Well, that's the same thing as 1/10 minus. How can we write 1 so it has the denominator 10? Right. That's the same thing as 10 over 10, right? 10 over 10 is 1. So 1/10 minus 10 over 10 is the same thing as 1 minus 10. Remember, we only subtract the numerators, and we keep the denominator 10, and that equals -9 over 10. 1/10 minus 1 is equal to -9 over 10. Let's do another one. Let's do one more. I think that's all I have time for. Let's do minus 1/9 minus 1 over 4. Well, the least common multiple of 9 and 4 is 36. So that's equal to 36. So what's negative 1/9 written as, where we change the denominator from 9 to 36? Well, we multiply 9 times 4 to get 36. We have to multiply the numerator times 4 as well. So we have -1, so it becomes -4. And then minus over 36. Well, to go from 4 to 36, we have to multiply this fraction by 9, or we have to multiply the denominator by 9. So we also have to multiply the numerator by 9. 1 times 9 is 9. So this equals -4 minus 9 over 36, which equals -13 over 36. I think that's all I have time for right now, and I'll probably add a couple of more modules, but I think you might be ready now to do the adding and subtracting module. Have fun.